Hi and welcome back to Podcast School. This is another A2 Technology and Design video podcast. Today we're going to again look at Karnaugh maps, and this time we're going to look at the rules that we can use to simplify those Karnaugh maps. Okay, so there is a standard Karnaugh map, a two variable one at that. It has two terms, A and B. And I've said there, in an earlier lesson we already saw how Karnaugh maps can be used to simplify logic. And indeed, in this occasion, you can see that there's a 1 in both the upper right and the lower right hand cell. That tells us that this Karnaugh map has an output which is independent of B, because in this top right hand case B is a 0, but in the lower right it's a 1. In other words, the output is high no matter what B is. If it's a 0 it's a 1, or if it's a 1 it's a 1. It doesn't matter what it is, so it's redundant. So that tells us that function Q, if they take the Karnaugh map as representing a function called Q, is represented entirely by the input A. Okay, we saw by looking at the Karnaugh map that the output is independent of B and B is redundant. I've already said that. Okay. Now there are 7 rules like this that we're going to use, and they're pretty much, I know you've heard these type of this said before, but they're pretty much golden rules. So if you learn these off, and they're not very difficult to learn, you will always end up with minimal expressions when you come to simplify your logic. Okay. So rule number 1 is groups may not include any cell containing a 0. So this is obviously wrong because a 0 is grouped here, whereas that would have been the correct way to group this. Okay, so that's correct. Now we're going to go through examples at the end, so don't worry if you're not too sure what's happening at the moment. Just watch this podcast and things might become clear. Rule number 2 is that you cannot group diagonal lines, so that's obviously wrong. But what you can do is have two groupings, like a L in the mirror. Okay, so you can do that type of thing. What you'll realize is that this grouping is just A, because we've said that already, it's independent of B. And this grouping is actually B because it's independent of A. So this expression, if this were a Karnaugh map or an output Q, the expression would be A or B, because when you've got two, what do we call these? When you've got two groupings, let's say, then it's ors in between, if you know what I mean. So this one is, say, A, and this one is B. So the output Q is A or B, and we'll see this much later on. This will become clear. Okay. The third rule is that you cannot you cannot have, say, 3 cells grouped. It must be of the order of 2 to the n. In other words, 1, 2, 4, 8 cells. So you can't group a 3 like that. That's definitely wrong. If you wanted to do that, then you'd have to group a 2 and a 1 separately. Okay, but this one on the right hand side, well, that's right because it's got 2 cells. That's fine. Again, this one's wrong because, can you tell me? Of course, it has zeros in it, and you can't group zeros. But look, this is right. In fact, you can group 4s like this. So this one's right. In this case, if this were an output, then the output is independent of A or B. It's always a 1. So they're both redundant. So this is a rather silly example, but it shows you that you can group 4. That's correct. Okay. Rule number 4 is each group should be as large as possible, resulting in as few groups as possible. Now this is actually, it's not wrong, but it's definitely not minimal. Alright, the way that should be grouped is like this, where you group your big 4 at the bottom and then another 4 at the side. Now, if you spent some time and wrote out the Boolean expression for this one, you would see that it's much more complicated than what this one would be. Okay, so maybe you should go ahead and do that now. It would be a good exercise for you to do. So this one, I'll start you off. This one would be Q equals, and then it would be A, if I'm looking at this one, A not B. So that would be A not B. This one would be, and then A not B, or not A, B. That would be that one. Or A, B. So that would be your final expression for if you grouped it like that. Whereas this one, well, this 4 here, that's just A, isn't it? And this one, well, that's just B. So the actual minimized expression from the Karnaugh map being grouped like this is A or B. Much more simple than this. So I've said that no Boolean laws are broken, but it's not sufficiently minimal. It's still wrong to do it that way. 5. Each cell containing a 1 must be part of a group if possible. So really, that's not the way to do it, but that is. Okay, can you see the difference? Rule number 6 is just, it's not a rule, it's just to say that they can happen. So you can overlap groups. So you shouldn't do it like this, you should do it like this one. Again, you'll end up with expression that isn't minimal if you try this one. 7. Now this is a really interesting one. You can wrap around a table. So if you've got ones in the top like here and ones in the bottom, you can group those as a group of 4. See that? In actual fact, this is represented by what? Well, you tell me what's common. The A's aren't common because A is 0 there and 1 there, so that's not it. B is 0 in this one, and it's a 1 there, so that's not common. The only common thing is C is a 0. So this grouping of an overlap 4 like that is actually not C. See that? Interesting. Okay, and you can do it with just a single row as well. Okay, you can do it with a single one. So in summary then, you're not allowed to group zeros, you cannot have diagonals, you must have a power of 2. In other words, it must be 1, 2, 4 or 8 cells in each group. Group should be as large as possible to obtain the minimal expression. Everyone must be in at least one group. Okay, you can overlap, and you are allowed to wrap around. You are allowed to wrap the table around, or the Karnaugh map around. That's quite an interesting one. Now again, I'll show you examples of all of this. So if this seems a little weird, just watch the following podcasts, and it should become clear. That's it for now. Until next time, then. Bye bye.